Hello everyone, my name is Terry Chang and today I'm going to introduce prime factorization and the least common multiple. So the first thing we'll learn is find the prime factorization of a composite number. Prime numbers have only two factors, the number 1 and the prime number itself. Composite numbers have more than two factors, and every composite number can be written as a unique product of primes. This is called the prime factorization of a number. When we write the prime factorization of a number, we are rewriting the number as products of primes. So on the right is the list of prime numbers less than 50. It's important, so we will use this list for the whole chapter. So just remember 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. And if you have time, you can search the list of prime numbers less than 100, because it's not a lot, just have to remember it. Prime factorization using a factor tree method. One way to find the prime factorization of a number is to make a factor tree. We start by writing the number, and then writing it as the products of two factors. We write the factors below the number and connect them to the number with a small line segment, a branch of the factor tree. So if we are finding the number for 36, we know it's 12 times 3, and we also know that 12 is 3 times 4, and 4 is 2 times 2. So we know 36 equals 3 times 3 times 2 times 2. So now you can try to find the prime factorization of 48 using the factor tree method. Write the products of circle numbers and exponential form. I already give you the factor tree method here, and you also know the circle numbers. So just find the exponential form of prime factorization of 48. For this one, I'll give you like 30 seconds to answer it. Okay, I think time's up. The answer for the products of the circle numbers is here 2 times 2 times 2 times 2 times 3. And exponential form is 2 to the power of 4 times 3. And if you want to check your answer, it's just see 2 times 2 is 4, 4 times 2 8, s times 2 16, and 16 times 2 is 48. Again, just find the prime factorization of 84 using the factor tree method. Find the exponential form and the circle number. I already give you the circle number, 2 times 2 times 3 times 7. This one is just like the same with the last one, so I will just give you 20 seconds to answer it. Okay, I think time's up. It's 2 squared times 3 times 7 is exponential form. Again, you want to check the answer, it's 2 times 2, 4, 4 times 21 is 84. Next, prime factorization using the ladder method. To begin building the ladder, divide the given number by its smallest prime of prime factor. For example, to start the ladder for 36, we divide 36 by 2, which is the smallest prime factor of 36. And it's 18, so we can also divide 2, which is 2 times 9. And then we divide 9 by 3, which is 3. So we know that the prime number of 36 is 2 times 2 times 3 times 2. 2 times 2 times 3 times 3. And if you want to check the answer, 2 times 2 is 4, 3 times 3 is 9. So 9 times 4 is 36. Find the least common multiple of two numbers. Back to ladder method first. I'll give you an example. To find the prime factor of 72, and you can write it on the paper or anywhere, and I'll give you 20 seconds, then I will tell you the answer. Okay, actually it's pretty easy because you already get the factor of 36. So we know that 72 is 36 times 2. So the answer will be 2 times 2 times 2 times 3 times 3. And if the question gives you a number like 9, so the smallest prime factor of 9 is 3. So we know that 9 divided 3 is 3. And because 3 is already the prime factor, so the answer will be 3 times 3. Or when the question gives you a number like 27, the smallest prime factor is not 2, it's 3. So your 27 divided 3 is 9, and 9 divided 3 is 3. So we know that it's 3 times 3 times 3. Next, find the LCM of two numbers. We can use prime factor method. The way to find this common multiple of two numbers is to use their prime factors. We will use this method to find the LCM of 12 and 18. We start by finding the prime factorization of each number. 12 equal 2 times 2 times 3, and 18 equal 2 times 3 times 3. So the LCM of 12 and 18 will be 2 times 2 times 3 times 3, which is 36. So using prime factor method, this ensures that 36 is the least common multiple of 12 and 18. So it's basically the smallest number that have 12 or 18 for its factors. Now you can try to find the LCM of 15 and 18 using the prime factor method. For this one, I'll give you 40 seconds. Just remember to find the prime factors. The prime number of 15, you can use either tree method or the ladder method. Anything times up. The answer will be 90, because 15 is 3 times 5. 3 is its smallest prime numbers. And for 18 is 2 times 3 times 3. So 15 is 3 times 5. 18 is 2 times 3 times 3. So we put 2 down, 3 down, and the 3 and 5. So it's 2 times 3 times 3 times 5, which is 19. So we can write that the LCM of 15 and 18 is 90. To check the answer, we can see 19 is 15 times 6, and 90 is also 18 times 5. Next, find the LCM of 50 and 100 using the prime factor method. For this one, I'll give you 20 seconds to answer it. Okay, I think time's up. The answer is 100, because the factor of 50 is 2 times 5 times 5. For 100 is 2 times 2 times 5 times 5. So 2 times 2 times 2 times 5 times 5 is 100. Again, we check the answer. 100 is 50 times 2, and 100 is 100 times 1. So it's least common multiple.